Section 6.2, multiplying and dividing rational expressions. Now, there's really nothing new in this section. All of the algebra that we need, we already have. If you look here at the beginning of the section, we have a blue box that talks about multiplying rational expressions. And it says P over Q times R over S is PR over QS. What's that say? Multiply the tops, multiply the bottoms. What else do we know about multiplying fractions? We know that you can cross cancel. So if we go back into section 6.1, here's this little blue box at the top of 397 talking about reducing a rational expression to lowest terms. Step 1, factor. Step 2 basically says cancel. Factor and cancel any factors common to the top and bottom. So to multiply rational expressions, knowing that we can cross cancel, we want to get everything factored, cross cancel what we can, and collect the surviving factors. Here on the third page of the section, page 406, dividing rational expressions. Well, it says P over Q divided by R over S equals P over Q times S over R. And so what does that tell me? Flip and multiply. Flip and multiply. So these are all rules that we already know just from knowing how to multiply and divide fractions and reduce them to lowest terms. Nothing new algebraically in this section. So we'll get right to the homework examples. Let's grab number 4. The instructions here read multiply. They could just as well read simplify, and of course you know we're multiplying, you see the multiplication dot. When you're multiplying, you can cross cancel. Is there anything here that will cross cancel? Well, I see this 7 and that 21 both contain a factor of 7. 7 goes into 7 once, 7 goes into 21 3 times. You're welcome to write the 1, but it's not going to do anything. I see this 18 and this 9 both contain a factor of 9. 9 goes into 9 once, 9 goes into 18 twice. And then I have these factors of b, top and bottom. 6 factors of b in the top, 4 factors of b in the bottom. How many are left and where when I'm done canceling? That's just our quotient rule for exponents. 6 in the top, 4 in the bottom. When I'm done canceling, that will leave me 2 factors of b in the top. We've cross-canceled everything that can be cross-canceled, so let's collect our surviving factors. In the numerator, we have a 3 and a b squared. In the denominator, the only thing that survived there was a 2. And that's all there is to it. Let's do some more. Number 8. We're multiplying, so we want to look and see if we can cross-cancel. Do you see any factors common to the top and bottom? Now I'm looking at the numerical factors, the 4, the 3, and the 6. I know that a lot of us would say the 4 and the 6 both contain a 2. The 4 and the 6 both contain a 2. 2 goes into 4 twice. 2 goes into 6 3 times. And then we see a 3 in the top, a 3 in the bottom, and those simply cancel completely. That's one way to do it. That's not what I see. Don't forget, cross-canceling has nothing to do with anything being diagonal. Cross-canceling means across the fraction bar. And so when I look at this, what I happen to notice first is this 3 and this 6. 3 goes into 6 twice. And now I notice the 4 and the 2. 2 goes into 4 twice. Well, I end up with the same surviving 2 in the numerator. So it doesn't matter how we approach that, as long as we get everything canceled that we can get canceled. What else do we notice? There's a factor of x common to the top and bottom. And is there anything else? We have a common factor of y minus 2. A common factor of y minus 2. 1 in the top, 2 in the bottom. How many are left in where when I'm done? When I'm done canceling, that will leave me 1 in the bottom. Now this is one of those places where if this were much messier, I would strike through the whole thing and rewrite that y minus 2 out here where I'm sure to see it. But if you want to just make your little mark through the 2 in this case, it's not too messy. Just be sure you collect all the surviving factors, which is the part we're at now. We've cross-canceled everything that can be cross-canceled, and so our survivors in the top, just that 2. In the bottom, the only thing that survived is that y minus 2. He doesn't need his parentheses anymore because he's the only factor in that denominator. All right, let's do a division problem. Number 18. To divide fractions, or indeed rational expressions, we flip and multiply. Leave the first fraction alone. Flip and multiply. Flip over that second fraction, changing this to multiplication. To divide fractions, we flip and multiply. Now that we're under multiplication, now we can look for cross-canceling. And here, number 18, let me show you what I see. I see a 35 in the top, and I see a 35 in the bottom. Do you see it? Here in the bottom, I have a 7 times a 5, don't I? And that's 35. So this 35 will cancel that 35. Or you could say 5 goes into 35 7 times and then cancel the 7s. Or you could say 7 goes into 35 5 times and cancel the 5s. But in the end, all that's going to be canceled. Now, look at the x's. Let me show you what I see. I see 14 factors of x in the top. I see 14 factors of x in the bottom. Are you with me? 14 x's in the top, 14 x's in the bottom. They're gone. The only surviving factor here is a 9 in the top. That would be 9 over 1, but I don't write over 1. Now, of course, you are welcome to cancel those x's in pairs. I could have said x to the 8 over x to the 9 leaves an x in the bottom. X to the 6 over x to the 5th leaves an x in the top, and those x's cancel. I could have canceled on diagonals and had what? An x to the 3rd in the top, an x to the 3rd in the bottom, and then my x to the 3rds would have canceled. But any way you go about doing it, when you're done, all the x's end up canceling each other out. Let's turn things up just a little. Now, a moment ago when we worked number 8, we got right to canceling. Everything was already factored. Number 34. When I'm multiplying fractions, I want to cross-cancel if possible. And the reason I want to do that, if I were to multiply this out right now, FOIL the tops together, FOIL the bottoms together, I would still need to get my answer in lowest terms. I would have to turn around and start factoring, and some of these, you multiply them together, you're going to end up with a monster to try then to go back and factor so that you can reduce to lowest terms. So it is vital that we cross-cancel when possible so that my answer will already be in lowest terms when I get there. If I'm going to be cross-canceling, I'm going to be canceling factors common to the top and bottom. If I'm going to be canceling factors, I need to see all the factors. So my first step here, get everything factored. This first numerator, I can factor out a greatest common factor of 8, which leaves r plus 2. This first denominator, I can factor out a greatest common factor of 24, which leaves r minus 1. Second numerator, pull out a 6, leaving r minus 1. And this second denominator, factor out a 3 to leave r plus 2. Now that everything is factored completely, let me see what I can cancel. Well, my r plus 2's will go. My r minus 1's will go. And I don't know, how do you want to handle this? Do you see the 24 and the 6? It's not what I see. You do it how you want. I'm going to do it how I want. We should come up with the same thing. I'm going to say 3 goes into 6 twice. 8 goes into 24 3 times. If you cross-canceled some other way, you should still end up with a surviving factor of 2 in the top and a 3 in the bottom. We have a blue box on page 407, multiplying or dividing rational expressions. Page 407 at the bottom. Step 1, note the operation. If it's division, flip and multiply. Step 2, you either started with multiplication or you changed division by flipping it and multiplying. So now we've got a multiplication problem. And I prefer to do these two steps in a different order. I'm going to do step 3 next. It makes more sense to me this way. Now, in her step 2, she says multiply the tops, multiply the bottoms. She doesn't mean to FOIL them out. You can look at her examples and see what she's referring to. But I'm going to go with step 3 next. So step 1, if it's division, flip and multiply. Now that you're multiplying, I want to factor all the numerators and all the denominators, and then I want to write in lowest terms by canceling. What that means is that my answer will be in lowest terms once I get there. So the way I would approach this blue box, I would say, if it's division, flip and multiply. Now that we're under multiplication, we either started with multiplication or we changed division to multiplication. Now, get everything factored. Cross-cancel any factors common to the top and bottom. Collect your survivors. If it's division, flip and multiply. Once you're under multiplication, get everything factored, cross cancel, collect survivors. Let's look at number 40. Okay, so my blue box goes like this. If it's division, flip and multiply. Now that you're under multiplication, you either started with the multiplication problem or you've done a flip and multiply to change division. Then what do? I want everything factored. I want to cross cancel everything I can. And I want to collect my survivors. That's how I would rearrange this blue box that she has, because that's what makes the most sense to me. So here we go. This is division. So the first thing we're going to do is flip and multiply. We leave the first fraction alone. Flipping the second fraction, so we can change this division to multiplication. Now that we're under multiplication, we can cross cancel, but only if we can see all the factors. Let's get everything factored. This first numerator, if it factors, will factor as a pair of binomials, each starting with z. Signs are the same, they're both negative. It has to be 1 and 2. Does that give me a -3 back in the middle? Yes, it does. In the bottom, if this factors, it will be a pair of binomials, each starting with z. Signs are the same, they're both plus. It's got to be 1 and 3, as long as that gives me a 4 back in the middle. Yes, it does. This second numerator is prime. In other words, it won't factor any further. So is the second denominator. Everything's factored. Now what do we want to do? Cancel any factors we find common to the top and bottom. Z minus 1 is gone. Z plus 1 is gone. Collect your survivors. Z minus 2 is the only survivor in the top. Z plus 3, the only thing left in the bottom. Again, I'll remind you, don't cancel those Z's, right? This does not reduce any further, because those Z's are terms, they're not factors. This does not reduce to -2/3. You can cancel factors top and bottom. You cannot cancel terms or factors of terms. All right, how about number 44? And now this time, this is another division problem. This time I'm not going to copy the problem to the board. I'm going to start with flip and multiply. So I've already performed the first step of flip and multiply. This was originally a division problem. I went ahead and flipped that second fraction so I could change it to a multiplication problem. We want to get everything factored, so we'll see what will cancel. This first numerator is a difference of squares. it will factor as the first plus the last times the first minus the last. This first denominator has a greatest common factor of 6 I can pull out, leaving 7 minus t. Second numerator, I can factor out as 6, which will leave t plus 7. And in this second denominator, if it factors, it will be a pair of binomials, each starting with t. Signs are the same, they're both plus. Two numbers whose product is 21, whose sum is 10. It's got to be 3 and 7. Everything's now factored. And look at what we've just had to do. In this one problem, just to perform this single step, we had to factor 4 different times. We had to do 4 factoring problems just to do one step of this, what started off as a division problem. Just to do one step, we factored 4 times. Let's get everything canceled that we can. What do you see common to the top and bottom? Those 6's can go. I see a t plus 7 that's common to the top and bottom. Now, I'm going to cancel them right here. There's nothing wrong if you cancel this t plus 7 with this guy on the bottom. It still leaves you what? It still leaves you a single t plus 7 in the top. I'm leaving that one. You might leave the other one. It's still going to leave you just with a single t plus 7 in the top. And is there anything else here that will cross cancel? Well, there are no other factors directly in common, but what do you see? Here's a pair of opposites. T minus 7, 7 minus t. Those will cancel and leave behind a factor of -1. Just a single factor of -1, either in the top or in the bottom or out front. Don't leave behind a -1 top and bottom. That makes no sense. I think we've cross-canceled everything that we can, and so let's collect our survivors. I'm going to bring this -1 out front as simply a negative on my fraction. My only surviving factor in the top is that single factor of t plus 7, whether it's this one or that one, depending on how you canceled. The only survivor in the bottom is this t plus 3. And there's my answer, with my negative out front from having canceled those opposites. Let's try number 46. Are you getting into the rhythm of these problems? If it's division, make it multiplication. If it's already multiplication, leave it alone. But once you're multiplying, what do? You factor, you cancel, you collect survivors. This one's already multiplication, so we're ready to start factoring. The only thing that might factor here is this first numerator. Let's see if it does. If it does, it will factor as a pair of binomials. It's got to start with 3x and x. There's no other way. Signs are opposite. Now, I may have those in the wrong place. We'll find out. The only way a 2 falls apart is 2 and 1, or maybe 1 and 2. If I put the 1 there and the 2 there, I check my outside and my inside. Outside is minus 6x, inside is plus x. That gives me back my minus 5x. So that's how that factors. Everything else here is prime. We cross-cancel what we can. The only thing that will cross-cancel is the x minus 2's. The x minus 2's will cross-cancel. And my survivors then, there's 3x plus 1 in the top. And now notice, here in the top, I have a couple of survivors, also my x minus 3. So I need these parentheses. I need these parentheses to show those two separate factors. In the bottom, There's only one factor that survived, the x plus 1, so he doesn't need parentheses. Let me mention now that we consider this a final answer. When we're dealing with rational expressions, it is generally considered appropriate and preferred to leave our answer in factored form. In other words, you don't need to FOIL out the top here. When we're working with rational expressions, it's generally considered appropriate and it is generally preferred that we leave our answer in factored form. I mean, we're always looking to see if it's in lowest terms. And so if it's in factored form, that makes things very clear. Plus, much later down the road, when something like this becomes part of an even bigger problem, that's a couple semesters away, don't worry about it. It turns out that the factored form works out better for me there also. So with rational expressions, these algebraic fractions, we typically leave our answer in factored form. Number 50. Number 50 is a multiplication. So once we get this copied, we are ready to factor, cancel, collect survivors. When I think about problems where I'm going to be multiplying and dividing rational expressions, this is the kind of problem that comes to mind. This is what I would call one of the quintessential problems of this section. Kind of just, what I expect to see when I'm multiplying or dividing rational expressions. We're already under multiplication, so we're ready to start factoring. We're going to factor, cancel, collect survivors. If this first numerator factors, it will factor as a pair of binomials. It's got to start with 2m and m. Signs are opposite. I need to break apart this 12 so as to get a negative 5 back in the middle. I know it can't be 2 and 6 or 6 and 2. That would create a magic greatest common factor. If it's 3 and 4, the 4 can't go here. So let's try a 3 there and a 4 over here. And I think we hit it the first time. The outside is minus 8m, the inside is plus 3m, and that checks. This first denominator, if it factors, it will factor as a pair of binomials. Each starting with m, signs are the same, in fact they're both minus. Product of 24, sum of negative 10, it's got to be minus 4 and minus 6. Second numerator, pair of binomials, each starting with m, signs are the same, both minus. Product of 18, sum of negative 9, negative 3 and negative 6. And this second denominator, that's a difference of squares. First plus the last times the first minus the last. Everything's factored. And here again is one of those problems where just to do this one first step, I had to work 4 different factoring problems. And notice it came from 3 different sections. The top here is 5.3. The bottom here is 5.2. This is also 5.2. And then section 5.4 for my last factorization. That's just to get one step of this problem done. Let's get to canceling. 2m plus 3, top and bottom. m minus 6, top and bottom. Here in the same fraction, doesn't matter. As long as one's on the top, one's on the bottom. The m minus 4s. And so I've canceled everything I can cancel. Collect my survivors. M minus 3. And in the bottom, 2m minus 3. Now, if this were multiple choice, one of my wrong answers would be 1/2. Because someone's going to cancel the m's and the minus 3's. If this were multiple choice, one of my wrong answers would be 3. Because someone's going to cancel the m's. That gives me 2 minus 3 in the bottom. Negative 3 over negative 1 is positive 3. The multiple choice answers are going to tempt you to cancel things that you're not supposed to cancel. It's important to know how to do the problem. It's just as important to know when to stop. We're done here. We're done. Nothing else will cancel because there are no factors common to the top and bottom. That negative 3, that's a term. M is a term of the top, and it's a factor of a term of the bottom. It's not a factor of the bottom. So it's important to know when to stop. It's important to know what you cannot cancel. So I want to finish up this section by giving you one to do. Let me have you do number 54. Number 54 is already a multiplication, so we don't have to flip. Once we get it copied down, we'll be ready to factor, cancel, collect survivors. Don't make these tougher than they are. Alright, why don't you go ahead and pause the video, come back when you're done, and we'll compare answers. We're going to start by factoring everything so we can cancel and then finally collect survivors. This first numerator, pair of binomials, each starts with z, signs are opposite, product of negative 6, sum of negative 1, it's got to be minus 3 and plus 2. This first denominator, pair of binomials, each start with z, signs are opposite, product of negative 8, sum of negative 2, it's got to be a negative 4 and a positive 2. Pair of binomials, each starts with z, signs are the same, they're both positive, product of 12, sum of 7, it's got to be 3 and 4. And finally, a difference of squares, first plus the last, first minus the last. We got everything factored. We start canceling. I'm going to get these z plus 3s. They kind of jump out at me being right on top of each other there. These z plus 2s as well. Anything else? Right there. Z minus 3, top and bottom. Question. Z plus 4, Z minus 4. Are those opposites? Because if they are, this whole thing reduces to negative 1. But no, those are not opposites. We talked about that last time. So collect your survivors. Z plus 4 in the top, Z minus 4 in the bottom, and there's nothing else I can do with that. That is in lowest terms. How'd you do? Like I said last time, if we've got 6.1 down pat, and we know our factoring, section 6.2 is really not that tough at all. If it's division, we flip and multiply. If we start with multiplication or after we flip and multiply, once we're multiplying, we do what? We factor, we cancel, we collect survivors. That's what it boils down to. Nothing new in this section. We already knew how to multiply fractions. We already knew how to divide fractions. We already knew how to reduce to lowest terms. So it's just a matter of getting in here, working some examples, and getting the feel of these problems.